final method that I can give you to kind of memorize this is a little bit more sophisticated, but is totally in line with what we talked about, well, I'd say about a month and a half ago, and it has to do with the unit circle. So if I were to draw a unit circle, and refresh your memory, a unit circle is a circle of radius 1 centered at the origin. All right, so this point right here would be 0, 1, or excuse me, 1, 0. This is 0, 1. This would be negative 1, 0, and this would be 0, negative 1. And that's what we call a unit circle. Now, what we said in general is that any point on a circle centered at the origin, doesn't have to necessarily be a unit circle, but any circle centered at the origin of radius r will have an ordered pair of r cosine theta, r sine theta. In other words, the x-coordinate will be r cosine of theta, the y-coordinate will be r sine of theta. So any point on a circle of radius r can be identified with this simple formula. So you take r times the cosine of theta, whatever angle theta is being carved out. We can go clockwise, we can go counterclockwise. It does not matter how you identify that angle. We can locate that point, its ordered pair, in the Cartesian coordinate system. Now, when you deal with a unit circle, what's nice about that is your radius is 1. So that simplifies our formula to any point on this circle is going to basically be cosine theta, comma sine theta. So what that means is if we look at these points as being angles carved out, and we can just go counterclockwise just to make things nice and pretty, we could say, okay, what is the measure of this angle? Well, it's 0 degrees. Let's think in terms of radians as well. 0 degrees, 0 radians. Well, the question is, what's the cosine of 0 degrees? The answer is, it's the x-coordinate. What's the sine of 0 degrees? It's the y-coordinate of that point according to this formula. And we can do that for every single angle that we carve out here, every single degree or radian. So up here, we're talking about 90 degrees, which is known as pi halves. Maybe we should do that. Always put it in parentheses for the radians. So the question is, hey, what's the sine of pi halves? The answer is, well, it's the y-coordinate, 1. What's the cosine of pi halves? Well, it's the x-coordinate, it's 0. And you go to 180 degrees. 180, in other words, pi radians, what's the sine of 180 degrees? It's the y-coordinate, 0. What's the cosine of 180 degrees? It's negative 1. 270, same thing. 270, do this. 270 is 3 pi halves. So again, what's the cosine of 270? What's the sine of 270? You can see that right there. Cosine of 270 is 0. Sine of 270 is negative 1. And if we complete the full revolution, we could say this is 360 and so on and so forth. Now, that works great for the quadrantals, and these are the points we actually plotted when we graphed sine and cosine, if you remember. For the other angles, it works the same. So let's start off with my best rendition of a 45-degree angle. Just trying to split this perfectly in half. Let's see. Close enough. Now, when we count this out, that's going to be 45. Plus 45 more is 90. Plus 45 more is 135. 45 more puts us at 180. 45 more, we're looking at 225. 45 more at 270. 45 more at 315. Now, if you want the simple radian conversion, each 45-degree angle represents pi force in terms of radians. So all you have to do is count by pi force to get the others. 1 pi force, that would be 2 pi force, which is pi halves. 3 pi force, let's put it below. 3 pi force, 4 pi force. This is 5 pi force, 6 pi force, 7 pi force. If you talk 8 pi force, you're talking 2 pi, which again is 360 degrees, but that's just repeating there. Right, now, as far as the points here, these 1, 2, 3, 4. The location of those points, again, the x-coordinate is the cosine of that angle, and the y-coordinate is the sine of that angle. So here, if the radius is 1, this would be the ordered pair square root of 2 over 2 comma square root 2 over 2. Which should look somewhat familiar because the cosine of 45 is the square root of 2 over 2. The sine of 45 is the square root of 2 over 2. Okay, as we go to 3 pi force, we just have to think, okay, it's the same thing, but we're in quadrant 2. Cosine is negative in quadrant 2, sine is positive. So this particular point, trouble here, it's negative square root of 2 over 2, square root of 2 over 2. Point down here, we're in quadrant 3, where both cosine and sine are negative. We'll try to make those both negative. In quadrant 4, only the cosine is positive, so we'll go with positive square root of 2 over 2 and negative square root of 2 over 2. So that takes care of the 45s and all angles that have a reference of 45. Right? Then there's the 30s and the 60s references. So don't know how this is going to work. Probably not very well. But the idea, well, at least start it off if nothing else. Right? We'll make that a 30. Like this. Try to make it look somewhat equal. Might be as good as it gets. All right, yeah, looks great. Okay, well the idea here is, now if we're talking right here, this is 30 degrees. That is pi 6. But if we count out, we would go 30. 30 more would put us at 60. 30 more would put us at 120, et cetera, et cetera. We can figure these out. And again, these points we can figure by, okay, the x-coordinate will be the cosine, the y-coordinate will be the sine. And if you're getting a little bit lost, it's still nothing more than right triangles. But the problem is our hypotenuse is not 2 like we'd like it to be. Our hypotenuse is 1 because it's a unit circle. So if this is 30 degrees, the side opposite the 30 has to be half of that, which is 1/2, which is actually what the sine of 30 is. It will be your y-coordinate of 1/2. Your x-coordinate has to be that side opposite your 30 times the square root of 3. Well, we don't usually say 1/2 square root of 3, we say square root of 3 over 2. And as I said, it's a little bit more sophisticated way of remembering these, but you can see the picture gets real cluttered pretty fast. If you go on the internet, they have much nicer pictures, these exact values. Though I think the chart or memorizing these right triangles or the right-hand method is probably the best way to learn these. Eventually we'll start learning these not as ordered pairs per se, but as just recognizing, okay, we got 30, we're doing the sine, that's going to be 1/2, or the cosine is square root of 3 over 2. Eventually we'll start coming to recognize those relationships.